Hello everybody, and welcome to the second section of this course, Applications of Recurrent Neural Networks. This is a very interesting section, so let's see what we are going to learn here. In the first video, we talk about the intuition behind recurrent neural networks, or RNNs, and we will talk about how these models are very useful and are built to deal with sequences. In the second video, we talk about time series forecasting. We will perform our first implementation of a recurrent neural network for predicting temperature. In the third video, we talk about producing word embeddings for natural language processing tasks. And this is a previous step for modeling text data. This is one of the techniques, one of the very important techniques for modeling text data. And finally, in the last video, we use a specialized type of recurrent neural network called LSTM, and we built one of these models to classify reviews based on the text of the review. So that is the plan for this section. Let's begin. This is the first video of this section, and here we talk about the intuition behind RNNs. Okay, so the plan for this video is the following. First, we talk about sequence data. Then we will talk about what are the type of sequences that we can find when modeling or when working with sequence data. And finally, we will talk about the high-level idea of recurrent neural network. We'll provide a very simple toy example of an RNN to give you a general sense of how this model works. Okay, so let's talk about sequence data. One of the key aspects of sequence data is that the order matters. And as we know, there are many problems when we have sequence data, like, for example, a video or audio recordings or language. It can be spoken language or written language, or all these variables where you have the value of the variable indexed by time. For example, temperature, daily temperature, or hourly temperature, or the stock price is indexed by hour of the day or the day. Okay, so these are all examples of sequence data. I have here a couple of examples. I have a sentence. This can be considered a sequence. So the food was really great and I enjoyed every moment in that place. Now, if you want to really understand the meaning of this sentence, you have to take the words in the right order. So if you change the order of the words, then you change the meaning of the sentence. So that is the key characteristic of sequence data. Here we have economic variable indexed by time. And again, if you change the order of these data, then you are going to change all the information contained in this sequence. So that is the key characteristic of sequence data. Now, another key characteristic of sequence data is that often they show dependencies. For example, here I have a simple sentence. The phone rang and I blank quickly. So previous elements, and here the elements are the words, previous words, give me enough context to place here a word that will make this sentence very meaningful, right? So I guess that you are thinking about the word answered here, right? So the meaning of the whole sentence depends on these previous words, and the word that you are going to insert here depends on the previous word. So that is what we mean when we talk about dependencies on previous elements. So therefore, if we want to make use of this kind of data, it will be really helpful to know how to use past information in the sequence to perform certain machine learning tasks. So, and this is essentially what we try to do in sequence models. Use past information in the sequence to perform some task. Now, when you are using sequence data for a machine learning task, for a supervised machine learning task, we know that in supervised learning we have inputs and outputs. So when we are using sequences, we are dealing with basically three cases. So if you have a sequence as input and your output is also a sequence, then we're talking about a many-to-many model. And an example of this will be translation. So you have a sequence of words that you want to translate from one language to another language. Then you have one sequence as input and another sequence as output. We're talking about many-to-many. The other case would be if you have a sequence as input and a non-sequence as output. That is, those kinds of models are called many-to-one. For example, sentiment analysis, you have a sequence of words and you want to predict if the sequence of words is related with a positive or a negative sentiment. So those are the kinds of models that we are going to work with, many-to-one. The other case is if you have something that is not a sequence as input, but you want a sequence as output. That case, is called one-to-many, and an example of a task like that would be image captioning. You input an image and you want a sequence of words that describes what's going on in the sequence. And finally, if you have inputs and outputs that are not sequences, well, then you are talking about regular machine learning, like regular classification, okay? So when dealing with sequences, we have essentially these three cases. And before trying to build a new model, you have to think about in which case you're working. Now let's talk about the models that the deep learning community has invented to deal with this sequence data. These are called recurrent neural networks. And these RNNs are designed for modeling sequences and are capable of remembering and using past information in the sequence to complete a machine learning task. Okay, so they operate in sequences. For example, if the input is a sequence, we have, sometimes you will see this notation. So you have the inputs and time step. So this index is called the time step. Now, sometimes this has nothing to do with time. So sometimes this has to do, for example, with order. However, usually we will call them time steps, even though sometimes, for example, in text, time is not something to consider, just the order. So this will be the first element in the sequence, the second element, and so on. Okay. So what these models try to do is to process the sequence element by element, and they maintain a state that contains information about past elements in the sequence. So this state is what they use as memory, right? So an approximation of memory. So what they do is, how they keep this state? Well, this is basically done by adding an internal loop to a regular neural network. Okay. So this is a high level overview. This will be like the pseudocode of a very simple recurrent neural network, but this conveys the general idea. So we start with an initial state. Then for every step in the sequence index, what we do is we get one output, and this output comes from a neural network. Now, this neural network takes two inputs: the input, time step t, and the current state. Okay, and then the next step is to update the state using the output. Okay, so in the next iteration of this loop, you will process, the next input and the state that contains some information about all the past inputs, and of course the output of previous steps. So this is one way to understand what RNNs do at a high level, or you will often see these types of diagrams. Now, you will often see these types of diagrams, or you will see these diagrams in an operation that is called unfolding, right? So this is representing this inner loop here with a sequence of inputs and outputs. So here you have one input step time at a step t-1. This gets processed by what we have here are called the cells of the recurrent neural network, and this is the whole layer. So here we have one output, the output at t-1. Then this information goes to the next step, and this is called the state. And here in the next step, it gets processed together with the input for this time step. And here we have some matrices that contains all the weights that are modified with the appropriate learning algorithm. So all these weights, the weights for processing the inputs, the weights for processing the state, and the weights that we have for the output, these are shared across all time steps. Okay, so this is at a high level how a recurrent neural network works. So now let me show you a toy implementation of one of these recurrent neural networks in the code. So let's go to the code to see that toy implementation. Okay, so here I am in this little notebook where I have a toy implementation of what is a recurrent neural network. Of course, this is just a toy example, but I want to give you some high-level understanding of what's going on with this model. So here we have a sequence. Here we have the time steps and the values of the sequence. Now, a recurrent neural network is basically this. So here we have a matrix of weights. This matrix will process the inputs. This is the matrix of weights that will process the state. And here we have a bias. So basically, internally, what's going on in the recurrent neural networks is in every neural network are set of matrix operations. So here we have tan H activation function, and we have one matrix multiplication of the inputs times this matrix of weights, and another matrix multiplication of the state times these weights plus the bias, right? So this is our little neural network. Now, for every time step, what we do is we have this initial state. So in this case, it's just an initial state of zeros. And what we do is that we calculate the output by using this little function that we built before, and then we update the state, and we do this with every element in the sequence in this for loop. And this is how the outputs look like. You know, as you can see, the outputs are, again, a sequence. And this is how the outputs of an RNN look like, okay? And sometimes we are interested in the whole sequence, or sometimes we'll be interested in only the last element of the output of the RNN, okay? So this is an example, but I am sure that it will give you a better high-level understanding on how these models work. Okay, great. In this video, we talked about the motivation and intuition behind RNNs.